Alright guys, we're finishing up 3.3 in this video. It's a real simple concept, looking at variation of signs and using Descartes' rule of signs. So simple concept, still working with the same stuff, finding zeros and the multiplicity of those zeros. Alright, so this is 3.3, continued still. So let me give you kind of the idea and then we'll look at a couple of examples. Variation of signs. Here's the definition of it. There is a variation of sign if two consecutive coefficients have opposite signs. So let me give you an example of what we're looking at there. Let's say f of x equals 2x to the 5th minus 7x to the 4th plus 3x squared plus 6x minus 5. All the definition is saying, when we're dealing with variation of signs, is every time we change signs going from consecutive coefficients. So from here to here, we go from positive to negative. From here to here, we go from negative to positive. From here to here, there's no change, right? We're going from a positive 3 to a positive 6. And then from the positive 6 to a negative 5, obviously we're going positive to negative. So that's really all the definition is saying. Two consecutive coefficients have opposite signs. Alright? That leads us into Descartes' rule of signs. This is in your book. On page 237, somewhere in there. Descartes' rule of signs. So, let f of x be a polynomial with real coefficients and a non-zero constant term. And Descartes' rule of signs tells us this. The number of positive real zeros of f of x is either equal to or less than the number of sign changes in f of x. Now, the one thing we need to look at is the number of positive real zeros in f of x is either equal to or less than the number of sign changes in f of x. When it's less than, in here we need to put in parentheses, it's less than by a positive even integer. So by a positive even integer. Okay? And we'll look at an example of this. Number 2 for Descartes' rule of signs. The number of negative real zeros of f of x is either equal to or less than, again, by a positive even integer. The number of sign changes in f of negative x. Okay? So here, it's either equal to or less than the number of sign changes in f of x for positive real zeros. For negative real zeros, it's either equal to or less than the number of sign changes in f of negative x. So let's look at a practical application as far as some examples are concerned, and you'll see that what we're actually doing is really quite simple. Alright, so first example, let's say f of x equals 3x cubed minus 4x squared plus 3x plus 7. Right? Well, we see that our n is equal to 3. So, we want to find the number of positive real zeros. Then we say f of x equals 3x cubed minus 4x squared plus 3x plus 7. And we want to look at the number of sign changes in f of x. Well, here's one here, we go from positive to negative. And then here's one here, we go from negative to positive. So we have 2 sign changes. Alright, that's step 1. Step 2, we want to find the number of negative real zeros. Well, here we need to do f of negative x. Well, f of negative x, that would be negative 3x cubed minus 4x squared minus 3x plus 7. Well, you can see that the number of sign changes here, these stay the same, these are the same. We only have one sign change. So we have one sign change. So what does this tell us? Well, number 1, right here, says we either have 2 positive real zeros or 0 positive real zeros. Because that's what the rule says. It's either equal to or less than the number of sign changes in f of x, and it's less than by a positive even integer. Well, we had 2 sign changes, so it's either equal to 2 or it's less than that by an positive even integer. Well, that only leaves one other option as 0. What does number 2 tell us? Number 2 tells us that we have exactly 1 negative real zero. So the final step of this, we can make a chart. We have the number of positive real zeros, the number of negative real zeros, and then we have the complex / imaginary zeros. Well, we know that this can be either 2 or 0. Negative has to be 1. Well, n is 3. So the number of zeros has to equal 3, which means this has to be 0 and this has to be 2. So when we add up our zeros, the possibilities must add to 3 because that's the degree. So we could either have 2 positives and 1 negative. We can have 0 positives, 1 negative, and 2 complex. And those are the only 2 options for that example. Alright, we got one more example to look at, and then we'll wrap up this video. Alright, example number 2. F of x equals 2x to the 4th minus x cubed plus x squared minus 3x and plus 4. And I'm going to go ahead and write f of negative x. And it's going to come out to 2x to the 4th plus x cubed plus x squared plus 3x and plus 4. So, what's the number of sign changes here? Well, we have positive to negative, that's 1. Negative to positive, that's 2. Positive to negative, that's 3. Actually, we have 4, because we go negative to positive there. So there's 4 sign changes in f of x. But how many sign changes do we have in f of negative x? Well, it's 0. Okay? So what does that tell us? Well, the number of positive real zeros can either be 4 or 2 or 0. The number of negative real zeros is just 0. So what does our chart look like? Positive, negative, and I'm going to put complex / imaginary. Well, we can have 4 positives and 0 negatives and 0 complex because we're dealing with the degree 4. Or we can have 2 positives, still 0 negatives, and 2 complex. Or we can have 0 positive, 0 negative, and all 4 zeros could be complex. So our totals add up to 4, which fits the degree that we're dealing with. So that's how we use Descartes' rule of signs. Again, the last 2 sections have been giving you ways to simply sketch a graph, finding intercepts and zeros without doing a whole lot of work. So finding turning points, things like that will become important later on down the line. So that's variation of signs and wraps up section 3.3.